Hello everybody, this is Dr. Christopher White, and in this video we are going to be looking at the earthquake location and magnitude assignment. So the assignment itself is 5 pages long. The first 2 are focused on earthquake location and the final 3 are focused on earthquake magnitude. So let's get going with the earthquake location portion first. So here we have 3 seismograms for Mesa View, Hillside and White Sands. Now if we come onto page 2, you will see that there is a map and you will see those 3 locations noted. So here's Mesa View, here's Hillside and here's White Sands. Okay, so what are we going to do first? Well, for each of these 3 seismograms you can see that we have a PS interval already noted for us. So for Mesa View it's 0.78 seconds, for Hillside it's 0.45 seconds, and for White Sands it's 0.25 seconds. So what we're going to try and do is we're going to try and work out how far from each of these monitoring stations the location of the epicenter is. Okay, so how are we going to do that? Well, we're going to do it using the trusty PS interval distance graph. So here the line has already been drawn for us, so yay, that makes our life a lot easier. So how are we going to do this? Well, I'm not going to show you the exact answer. So what I'm going to do is I'm just going to give you an example about how we're going to do it. So let's, for argument's sake, say that the PS interval was 0.6 seconds. All right. So what I'm going to do is I'm going to go to Insert. I'm going to go to Shapes, and I'm going to get myself a line. Okay. And I'm going to draw a line going from 0.6 here, straight up till I hit the line here. Okay, there. So now I've hit it. Now what I'm going to do, just because I like to make sure I can see my lines, I'm going to just, there you go, make it red and increase the weight. So there it is, there's the line there. And then I'm going to get another line and I'm going to come across. There we go. Once again, make it red and make the weight 1.5. There we go. Okay, so if my PS interval was 0.6 seconds, that equates to a distance of 6 kilometers. Now remember, that's 6 kilometers from the monitoring station. It doesn't tell you which way. So it doesn't tell you whether that's north, south, east or west from the monitoring station. It just says 6 kilometers from this monitoring station in any direction there could have been an earthquake. Okay? So how are we going to turn this into useful information? Well, the next thing is we're going to do the other 2 locations. So you'll do the PS interval for Hillside and the PS interval for White Sands. Okay, so I'm going to see essentially 3 sets of lines on this diagram, 1 for each different location. Okay, so I'm going to see a vertical and a horizontal for each of these different locations. Understood? Now, once again, just to be 100% clear on this point, the lines I have just drawn here do not apply to Mesa View. This is an example. Now, once I have worked out the distance, what I'm going to do with that, we will see down here there's a table, and here we have the 3 different locations, and here's Mesa View. And so if my distance from Mesa View was 6 kilometers, well, what I would do is I would highlight the correct box. So I'd essentially make it red, and I would embolden it as well, and I'd say, right, that's the correct distance, 5 to 6 kilometers. Then I'd do the same for Hillside. Let's say Hillside is 3 to 4 kilometers. Then I would, and White Sands is 4.5 kilometers. And obviously these values are going to be based on the distance values I get from my graph. Okay, so for each of these 3 locations, I'm going to get a distance value from the graph, and I'm going to use that to select the correct distance from earthquake using the 5 possible answers provided here. Okay, so that bit I think we can agree is quite simple. So what are we going to do next? Well, what we're going to do next is we're going to come on to page 2, and we're going to use this distance information to start drawing some circles. Now, if we were in class, this would be rather straightforward. We would just get a compass, but we're not in class. So how are we going to do this? Well, the first thing we're going to do is we're going to zoom in on page 2. Alright, I'm going to delete that minus sign that I drew accidentally. Okay, so you will notice that here we have a 1 kilometer scale bar. Now the first thing we're going to need to know is how long is this 1 kilometer scale bar. Now if we were in class, we would measure it with our trusty ruler, but we're not in class. So how are we going to do it? Well, if you're going to insert, and if we get ourselves a line again, now let's just draw that line. So we're going to start where the white line starts, and we're going to finish where the white line finishes. Okay, so there's our line. Now the really great thing about programs like Word is if you go to Format, on the right hand side here, it will actually tell you the length of the line. So it's telling me the length of this line is 1.74 centimeters. That's pretty useful. So I now know the length of this line here. So I know what 1 kilometer is on this diagram. 1 kilometer is equivalent to 1.74 centimeters. Alright, so I'm going to zoom out now. Oh, maybe a smidgen too far there. Okay. So what's next? Well, we know that Mesa View is 6 kilometers from our earthquake, don't we? All right. Now we don't know what direction that is, but we know Mesa View is 6 kilometers from it. So how are we going to use that data? What we're going to do is we're going to come back to our diagram here, and we need to calculate what the diameter of the circle would be on this diagram. So in order to do that, we're going to break out our trusty calculator, and we're going to do a very simple calculation, which is going to be 6, which is the distance from Mesa View to our earthquake, multiplied by, nope, didn't need that, 6 multiplied by 1.74, and that's the length of our line, the length that represents 1 kilometer. Okay, and the answer is going to be 10.44 centimeters. Now, we also need to remember that this is a radius, and so when we draw our circle, we are going to need diameter. So what we need to do is we need to take our 10.44 centimeters and we need to multiply that by 2. Okay, because remember 2 times the radius is the diameter. So that's going to give us a diameter of 20.88 centimeters. Okay, so now we've calculated that and we know the diameter of our circle. So okay, what are we going to do next? So we're going to come back to insert, okay? We're going to draw ourselves a circle. Okay, so here's the circle tool, and as you can see I'm going to start drawing a circle here. Now, one of the great things you can do on programs like Word is if you hit the Shift key, you'll notice it will make your circle a perfect circle. Okay, so hold down the Shift key, perfect circle, let the mouse button go, and there you go, you've got yourself a nice perfect circle. Now, as per usual, I'm going to make that circle red. I'm going to make the line a little bit thicker. But the other thing we're going to have to do, because it's a shape, you will notice that it is white on the inside. And we want to get rid of that. So what I'm going to do is I'm going to go to Shape Fill, and I'm going to set it to No Fill. So there's nothing in the middle of the circle anymore. Alright, so we have our circle. Then what are we going to do? Well, once again, if you go to Format, you'll notice that the height and the width of the circle are listed right here. And we can change them. So we need to change them to 20.88. So we're going to get rid of this. And we are going to type in 20.88. Return. And all of a sudden, whoop, there we go. Our circle has grown significantly. Going to do the same thing here. 20.88. And return, and here we go. So this is our circle for Mesa View. So in theory, once we've got this circle on Mesa View, this line marks the possible location for the earthquake. So what I'm going to do is I'm going to move this circle, and I'm going to try and center it on Mesa View. What I'm going to do is I'm going to use these squares here to try and essentially position it correctly, because these squares are essentially going to be on north, south, east, and west positions on the circle. So I'm going to try and line them up with Mesa View. So this one is actually pretty much lined up, but this one is not. So the circle needs to come to the right a little bit. Still not quite there. Maybe a smidgen more. Yes. Actually, maybe I went too far there. That's got it. Okay, good. So Mesa View is pretty much falling in the center of this circle now. All right. So what we're going to do is we're going to repeat the process for the other two locations, Hillside and White Sands. All right. So the numbers you're going to use for the diameter of your circle are going to be the numbers you take off the graph here. Okay. Now try and keep them simple numbers. Try and keep them like, 0.5, 1, 1.52, 2.53, 3.54, etc. Don't try and be overly complicated about it. All right. Oh, there's my dog. So, okay. So we're going to have 3 circles on this diagram here, and hopefully those circles will all intersect at one point. And where the 3 circles intersect, that is the epicenter of your earthquake. And just for a little bit of style and panache, once you've actually worked out where the epicenter of your earthquake is, maybe you can go mad and draw yourself a star. There we go. Why not fill that in yellow, for instance, and then place this over the location of your earthquake. Done. Okay, so I think you can agree, the first 2 parts of this lab are quite straightforward, aren't they? So I hope that all made sense to everybody. I think you should be able to do it with relatively little trouble. All right, so let's move on to the magnitude portion of the presentation. Well, presentation, assignment. So we've already seen one of these diagrams before as part of the lecture. So what do we have going on here? Well, on the right hand side we have the amplitude. Now this is to do with the seismograms we're going to look at later. In the middle here we have the magnitude. Okay, now this is the Richter magnitude. So when they say 7.8 on the Richter scale, that would essentially be 7.8 on this column here, would sit about there. Okay. Over here we have a line which has distance on this side and SP lag time on this side. Okay. Now for this lab, the distance is going to be the important bit for the time being. Okay. So for the first part, what we have here is we have a table. In this table we have amplitude and distance. And so what you're going to do is you're going to draw a line between these 2 points, between the 2 data points listed here, and you're going to note what the Richter magnitude is. So once again, go to insert, go to shapes, get the line. So we're going to do the first one here, amplitude of 1, distance of 100. All right, so here's amplitude of 1, distance of 100. So the magnitude is going to be, well, you can, if you can't read it, you can do it yourself. Okay, now please leave that line on the diagram. Okay, so I want to see all the lines on your diagram so I can see you've actually done it. All right, now if you want to, you can go mad, you can color lines. Now obviously, once again, because I'm a bit obsessive, I'll just always make the lines the same thickness. There you go. So that would be the line for your first part, and then you would write the answer here. Then you would do the second one, amplitude of 10, distance 100, amplitude of 100, distance 100. You would essentially end up with 6 lines and 6 different Richter magnitudes, all using this diagram here. Okay, so that was the first part. So this is just showing you exactly what you've got to do. So once you have data for this line here and this line here, you can essentially just draw a line between the 2 points, and it will intersect the magnitude line in the middle. And the magnitude, and then all you have to do is read off the scale what the Richter magnitude of the earthquake was. So not too tricky. Okay, so now we're going to go on to something which is a bit more complicated, and this is the part of the lab that's going to take a little bit of effort. It's not terrible, not too bad, but I'm just warning you ahead of time. Okay, so here we go. So here we have 3 seismograms. Okay, now we can see on these seismograms that we can spot the individual parts. So these lines here, okay, that's our background. So you can see the line is relatively flat. There's a little bit of variation. If we look at this one down here, you can just see there's a little bit of variation in it, but on the whole, the background is relatively flat. So all of a sudden, where we see the amplitude, the waves start to get higher, that's going to be the arrival of the P waves. So that's where the arrival of the first P wave is. So then we're going to have this portion here. So this is all P waves, and then all of a sudden, bang, you get this next jump. So this is going to be the arrival of the S waves. So on our diagram, we can work out where the P waves first arrive and where the S waves first arrive. Okay, so we know those two bits of information. The question is how can we turn that into a PS interval? Okay, so we're going to need a PS interval for each of these three seismograms here. So how are we going to do it? Well, once again, we're going to come to our trusty line tool, and we're going to draw a line from the first appearance of the P wave all the way straight down. Now I'm going to try to make sure my line is straight. There we go. Okay. Now once again, I'm just going to make my line yellow because, stuff. Okay, so that's the arrival of my P wave. So now I'm going to do a line for the arrival of my S wave. So my S wave is making its appearance about here. Once again, I'm going to draw a line straight down. There we go. Going to make that one yellow as well. And so what we can do is we can read off the length of time on the scale down here. Now it's a little bit tricky to do it this way. So what I tend to do is I tend to draw a third line, because why not? And I will draw a third line between these two lines here. Okay, and I'll typically make that another bright color. So in this case, I'll make it orange. Okay, then I'll take this orange line. Oh, that wasn't smart, was it? Let's try that again. Then I'll take this orange line and I'll then put it down here on the diagram. There we go. And I can see that this PS interval is 10, 20, about 25, 26 seconds in length. Okay, so I hope that was relatively straightforward. Just draw a line showing the first arrival of the P wave, then draw a line showing the first arrival of the S wave, and then you work out the distance. Well, just draw a line in between the two, and then apply that line to the scale down here, and just read off how many seconds that that is. Okay, so for the top one here, I'm just going to insert a text box. Actually, do you know what? No, that's a silly thing to do. Gonna get rid of that. No, there. I keep doing stupid things. There we go. So for the first line, okay, that was also a silly thing to do. What's going on there? So for the top line, the PS interval was, if I look at it, I'm going to say 26 seconds. Okay. Now obviously you'll then do the same thing for the middle and the bottom. Okay, good. So what are we going to do next? Well, what we're going to do next is we're actually going to delete those lines because we don't want a load of clutter on our diagram. It's just going to get in the way and confuse us. It would really help if I could select this line here. There we go, and get rid of that. Okay. So what's next? Well, the next thing we need to know in order to work out our magnitude is we need the amplitude. Okay, so if you remember, the Richter scale uses the amplitude of the largest wave. Okay, so here we go. Now the amplitude in this case is going to be the height of the largest wave from the top down to the bottom. Okay, now once again we can use a line to measure this. So where's our largest wave going to be? I think it's going to start here and it's going to come down to here. Okay, so I'm going to call this my largest wave. So there we go. So that's the largest wave there, in my opinion. So what's the height of that? Well, I'll select the line. I'll of course go to Format, and here it is, 2.66 centimeters. Okay. So do you know what? I'm just going to keep everything consistent. So amplitude. So the wave is 2.66 centimeters in length. So how am I going to use that? Well, the first thing is I can't use that straight away on my diagram on page 3. Okay, I can't go there straight away. I have to use this. So there is a conversion factor in order to convert the height you measure here in centimeters into the true amplitude that you will apply to this diagram right here. Okay? So how are we going to make this easier? Well, we know to start with that 2.66 centimeters is equivalent to 26.6 millimeters. Okay, now that's going to be important later on. Now, what we're going to do then is we're going to take our measurement here, okay, and we are going to divide, essentially, so we're going to divide this, and we're going to, so what we're going to do is we're going to take the amplitude up here, and we're going to divide it by 10. So why are we doing that? Well, of course, there's 10 millimeters in 1 centimeter, so we want the amplitude for every 1 millimeter. So we're going to do 756 divided by 10, which is going to equal 75.6. Okay, so now what we're going to do is we're going to take our amplitude that we measured, 26.6 millimeters, and we're going to multiply it by 75.6. So we're going to do 26.6 multiplied by 75.6. Okay, I forgot to put the equal sign there. There we go. Okay, then we're going to come back to our trusty calculator, which of course, there we go, I lost it for a second, found it again. Clear that. So we're going to do 26.6 multiplied by 75.6 gives us quite a large number, which I of course can't keep. So there we go, that's not really helpful, so I'm going to drag this over here onto my other desktop. So the number in question is going to be 2010.96. Now please, I know I've just worked this out, but it's not going to hurt for you to do it for yourself, okay? It's going to be quite a good exercise for you. It's going to help you make sure you get the other 2 right. Okay, so now we have our true amplitude, which is going to be, there we go, let's once again embolden that, maybe put it in red, 2010. Okay, we also have our PS interval, which is 26 seconds. So we'll put that in red as well. So those are our 2 important pieces of information. So what we can do then is we can come up here to our graph. So here's our PS lag time, also called the PS interval. So we're going to find 26. Where would that be? So obviously we're going to insert a line here, insert shape, line. So we're going to come up here. There's 20, 20, there's 30 there. So 25, 26 is going to fall about in the middle. And then we're going to take this line up to 2000 over here on the amplitude scale. Okay, and then we're going to draw that line. So by doing that, we're then going to get the magnitude for that earthquake. Now, then you're going to do exactly the same thing for this earthquake and this earthquake. And eventually you're going to get the PS interval, time, you're going to get the amplitude, you're going to put that information onto this diagram here, and it's going to give you a point, hopefully, where the 3 lines intersect with each other, and that is going to be the magnitude of your earthquake, which you are going to write here at the bottom of page 4. And that's it. So it's a relatively simple lab. Shouldn't take you too long, hopefully. So Best of luck. Take care.